this lesson looks at the sine law and the cosine law. These laws are going to be very useful for solving oblique triangles. Oblique triangles being triangles that do not have 90 degrees. So remember, SOHCAHTOA and the Pythagorean theorem do not work for oblique triangles. Those only work if you have 90 degrees. So an oblique triangle can be split into two smaller triangles of 90 degrees by looking at the height. Say, for example, this way. You could also drop it down this way and drop it down this way to find the other options. But let's just look at this case here. And let's call these points, say, angle A, angle B, angle C. And so therefore, if this is A, then this is little a because it's right across from it in the orange triangle. And that's C, so this is little c, and that's B, so this is little b, this whole thing here. Now, this height is going to split it into right triangles, and we know how to deal with right triangles. So let's see if we can connect these theories a little bit and adapt what we know for right triangles to oblique triangles. So, since we know the height is the same, we can actually look at two positions. So let's say there's the position of looking through A, and so then H is the opposite and C is the hypotenuse, leaving us with sine of A being the proportion of opposite to hypotenuse, H over C. But that just means that H is equal to C times sine A. Okay, now let's look at the other perspective here. So let's say you're looking from C, then H is the opposite and A is the hypotenuse. So you can simultaneously say that sine of C is equal to the opposite, which is H, over the hypotenuse, which is A, meaning that H is also the same as A times sine C. Since our h's are the same, we can equate them, and so we know that C sine A is equal to A sine C. So in this way, we've created a new proportion that will work for oblique triangles, and this proportion doesn't use h. It's only dependent on the sides and the angles in the oblique triangle. This is great. However, it's a little more useful when we see it as proportions because they're easier to solve that way. So let's just rewrite this so that we divide out both these signs. So what ends up happening is you end up having C over sine C and A over sine A when you manipulate it. Now you can check that, but you can also see that A times sine C is the cross multiple here, C times sine A is the cross multiple here. It's just an algebraic manipulation dividing by sine A sine C to get there. And so now we have this proportion. We know that A to sine A is the same proportion as C to sine C. Now if you flipped this triangle around and did the same process with the other side, so saying the height being here or the height being here, you'd end up getting all the other parts. So what ends up happening is you end up finding out that A to sine A is the same proportion as B to sine B is the same proportion as C to sine C. Now this proportion is called the sine law, and it's very useful in that when you have an oblique triangle, you can fill in some parts of this and treat two at a time. You always treat two at a time. Say that, for example, you can treat it as a proportion and you can solve for the missing parts. So, to recap, the sine law can be seen as one of these two forms, either A to sine A, B to sine B, C to sine C, or you can flip them all around and you get sine A over A, depending on what's more useful at the time. It's not a big deal which one you go with. So this sine law is the most useful when you are given in the oblique triangle a pair of opposite data. So what that means is if you have angle A and side A, that's going to be very helpful because then you know one part and you can choose which other part you need to fill in to make your proportion. So say you know A, you know little a, and say you also know C, so side C. So if you're given that, then you could set up the proportion of sine A to little a is equal to sine C to C. And since you know C, you know A, you know little a, all you need to find is this C. So then you can cross multiply and divide and solve for sine C. You'll have some number, and then you can find the sine inverse, and you'll find what angle C is. So let's take a look at some examples of that. Here's a triangle, and also creating these triangles, you have to remember that the opposite side to the letter will be the little letter. So if you know angle A is 20, and note that sometimes the picture doesn't really reflect the actual angles. As long as these are opposite to each other, that's great. So angle 20 gives you side 11, that's little a, and side B is 7, so I'll say this is side 7 here because, so then that means that's big B, that's little b, and so that's big C, angle C, and little c. So what we need to find to solve the triangle is find all the missing parts. Well, what's missing? Well, angle C is missing. And you can write the angle symbol, or sometimes you don't need to, depends on the textbook or the context. So you've got angle C, angle B. We don't know either of those, and we also don't know what little c is. That's what we need to find. So recall that sine law will let us relate things and will be useful to us if we have a pair of opposite data, and we do. We have A and little a. So I'll use the first form of the sine law. It really doesn't matter which one you choose. So you've got 11 over sine 20 is equal to, and now you can choose, are you going to relate the B's or the C's? Well, the C's don't have any information, so that won't be helpful. We'll have two missing pieces. We can't solve for that. So we want to choose the B part. So we'll know that 7 over sine B is going to be then the same proportion. And this will allow us to solve for B. So either way, if I wrote it the other way around, I'd still need to cross multiply and divide. So it really doesn't matter which way you write it. So this tells us that sine B is equal to 7 times sine 20 divided by 11 from cross multiplication. So let's find that. 7 times sine 20 and then divided by 11 will give you 0.217649. And then to find B, you want to find the sine inverse of whatever that gave you. And when you take the sine inverse of that, you should get 12.6 approximately, 12.57. So that tells us B. Angle B is 12.6, and make sure you write the degree symbol for angle, or you can signify it's an angle with the angle symbol. So we have B, great. Well, since we have B as 12.6, that also tells us what C is because a triangle adds up to 180 degrees. So 180 minus 20 minus 12.6 is going to be angle C, which is 147.4 degrees. So now all we need to do is find C. So we can redo the sine law for that proportion. We can use 11 over sine 20 again. We know that proportion is the same as the C proportion, which will be C over sine of 147.4. So solve for C, that'll be 11 times sine of 147.4 over sine of 20. So when you type it in, make sure to include brackets. Sometimes that causes some issues if you're trying to type it all in. So calculators usually have a bracket there. They open up, and if you forget to close it, then it will cause some problems. So that should give you C equal to 17.3. And so that's your length there. Try this next one. See if you can get it on your own, and then come back to the video and check it out. So we've got a triangle. Say we know angle B is 65. It doesn't matter where you write it. We also know that angle C is 15. And then B, little b, which is across from the 65, is 12. So that means A is here, and little a is here, and little c is here. We have a pair of opposite data, so that's great. So we know already that 12 over sine 65 is something we can relate the other proportions to. We also know that the c's are the next best option to compare to because we have the angle C. So we know that C over sine 15 is going to be true. So we can solve that. So C is going to be 12 times sine 15 over sine 65. And when you punch that through, you get 3.43. So let's just round it to 3.4. So that was one of our missing sides. C was 3.4. We also know that angle A is just going to be the sum of 180 take away 65 and take away 15. So that's 100. We know C, and so now we just have to find little a, and we can do that with another proportion. So we know 12 over sine 65, and then we also know a over sine of 100. And so you just play with this proportion and see where you get to. You could have done it a different way, but you should still be getting the same answers. So again, this will be 12 sine 100 over sine 65. 12 sine of 100 over sine 65, which is 13.04. I'll round it to 13. That's fine. So you've got your missing pieces, and that's the solved triangle. So let's apply this. Say you have two houses. They're located on opposite sides of a river at points A and B. So let's sketch that out. You have a river, and they're on different sides. Say you've got point A and point B. In order to measure the distance between the houses, a measurement was taken from a third point C, which was located 350 meters from A. So let's say there's C right here, and that's 350 meters. On the same side of the river. Find the distance between the two houses, which is this distance. If BAC, this angle, is 62 degrees and 50 minutes. So this is 62 and 50 minutes. Now let's convert this to decimal because it's easier to work with then. So this will be 62 plus 50 out of 60, which is 62.83 repeated. So that's 62.83. And the other angle, let's convert that. That's 38 plus 20 out of 60, which is 38.3 repeated. So that's ACB, which is this angle. 38.3 repeated. So we need to find x. Now, do we have any opposite data? We don't. However, we know that this angle will add up to the triangle of being 180. So 180 take away 38.3 repeated, take away 62.83 repeated. and that's going to give you 78.83 repeated. So let's say that's 78.83. So now we have a pair of opposite data. So we know that 350 out of sine of 78.83 repeated is the same as any of the other proportions. And the other proportion that we need is the one that's going to give us x, which is x over the sine of 38.3 repeated. Now when I type in repeated, I just type in a bunch of threes just to give it more accuracy. So when we cross multiply and divide, we get 350 times sine of 38.3 repeated over sine of 78.83 repeated. And this gives us 221.27 meters as the distance between the two houses. And they didn't have to cross the river.